Good morning. This is Akanksha Shukla from Information Technology Department. Today my topic is statistical graphics, which I study in human computer interface subject. So basically the goal of statics and why we use statistical graphics, first of all I will discuss these points. Basically the goal of statistics is to present the data in a meaningful way. Suppose if we have to present the data in a textual form, then that data might be not be able to be clear to the viewers in comparison to the statistical graphs, or somehow when we use the tabular formats. So these kind of representations can be better understandable by the viewers. So the same goal can be fulfilled by using the statistical graphics. So one of the primary goal of statistics is to present the data in a more meaningful way, and often we can see that the data sets involve the millions of the values or a huge amount of the values in it. So this is far too many to print out in a journal articles or the sidebars of the magazines stories. So that's why where the graphs can be invaluable, allowing the statisticians to provide a visual interpretations of that numerical stories which are very complex. So basically today I am going to discuss here the 7 types of graphs which are commonly used in statistics. Apart from these 7 kinds, there are many more statistical graphs, or there are many more graphs which we we can use to represent these statistics. So basically what is the characteristics of the good graphs? So good graphs can convey the information quickly and easily to the users, and it can be able to represent the information or to convey the information in a more meaningful way and in a more easily understandable manner to the viewers. So graphs basically what they did, they highlight the salient features of the data, and also they can be capable to show the relationships which are not be seen obviously from the from studying a huge amount of a list of numbers. So they can also what is the next characteristics of the good graphs, that they can also be capable, or they can also be able to provide a convenient way to compare the different kinds of data or different sets of data. Suppose if we have a different kinds of data, just like we have a student list of mechanical branch, of IT branch, of CSIT branch, of civil branch. So I am having a different sets of data, but using the graphs, or if you are using a good statistical graphs, then there is a convenient, or there is a systematic manner through which we can differentiate, or through which we can differentiate these sets of data into a more meaningful or into a more easily manner. There are different situations which are we used to call for different types of graphs, and basically it helps to have the different or to have a good knowledge of what types of graphs are available. So the type of data often determines what graphs are appropriate to use, and as we all know that we have various kinds of data, just like qualitative data, quantitative data, paired data. Each kind of data can use the different types of graphs for their convenience. So as per the requirement, or as per the need for the different sets of data, we have a different types of graphs to represent that kind of data, or to represent these sets of data which are having the different kinds of elements in it. Now, what the statistical graphs are able to provide? Basically, the statistical graphs are able to provide the proper context for the data interpretation purpose, and also the scales or shadings which are used in statistical graphs. They can place the text to the marks scales on the outside edges of the each axis. They are also capable to employ a linear scale. Also, they can mark the scales at standard or customary intervals. They also start a numeric scale at 0. They can display only a single scale on axis also. Sorry. They are also able to provide the aids for the scale interpretation, clearly label the each axis, Basically, what statistical graphics, the features or the purpose of using statistical graphics are, they can be able to clearly label the each axis, they can employ a linear scale, they can start a numeric scale from 0 or at 0, they can also be able to display only a single axis, only a single scale on a axis. The axis can be positive, negative, can be both as per the requirement or per the data sets which are available at that time. It also provides the scaling consistency. They also consider the duplicate axis. If we are having a large scale data, then statistical graphics can also consider the duplicate axis for displaying or for viewing the large scale of data. So, proper proportion of particular sets of particular elements of data, proper linings, proper labelings, proper titling and proper interpretations of the numbers. So, these all are the features or these all are the characteristics which the statistical graphics can be able to properly convey these things over the scales. Whether the data is a normal scale data or a large scale data or a small scale data, it sets the axis as per the requirement or as per the data sets requirement. Now, there are various kinds of statistical graphs. As I said earlier also, that I am going to discuss here only 7 kinds of graphs which are generally we use, but the different kinds of statistical graphs and what they be able to display the information. So, these kinds of statistical graphs are as follows, just like curve and line graphs, 4 or 5 maximum, legend, important or critical data, comparing actual and projected data. We can also say that these kinds of things can also be properly viewed or properly represented by also the statistical graphs. So, some graphs just be able to simple compare the actual or projected data. So, these kind of graphs we can say as comparing actual and projected data. Data differences, some graphs can be able to show only the data differences between the different sets of elements of between different kinds of elements. So, data differences. Ordering, some graphs simply used to order the elements or of the different kinds of data. So, basically these kind of graphs can be known as ordering. Labels, some kinds of graphs can also be used to simple label the data, 2 dimensions, multiple data sets. Bar graphs, which we are already or which we are more familiar for by this graph, bar graphs. Meaningful organization, differentiation, single graph, label identification, tightly packed curves, surface charts, coding schemes, scatter plots, consistent intervals, significant points, consistent orientation, bar spacing and important or critical data sets. So, these kinds of different kinds of statistical graphs are basically used for the different purposes or for showing the different requirements of the data or as per requirement of the person or of the user. Now, related bar ordering, labeling segmented or stacked bars, data category, flow charts, orientations, arrows, one decision at each step, pie charts, large segments, highlighting, reference indexes. These all are the some extension of the previous types of graphs. So, in this we can see that some of the graphs we are already familiar, just like bar graph, pie charts and flow charts. Basically these kinds of graphs are or simply they used to simply show the how the, just like for example, if you are taking flow charts. So, what is the purpose of the flow charts? Basically it shows the start and end of the problem. Between this start and end of the process, it shows how the data flows from one step to another step, just like this. So, simply the purpose of the statistical graph is only to deliver the information which can be adopted by the viewers or by the users in a more convenient or in a more meaningful manner. So, that is the only purpose of statistical graphs. Now, I am going to discuss 7 graphs. First one is Pareto diagram, which is also known as bar graphs. So, this bar graph or this Pareto diagram is a simple way which is used to visualize the or which is used to represent the qualitative data. Okay. So, Basically, what is the difference between quantitative data or qualitative data? So, quantitative data is those data which consist of only numeric things, just like the number of students in a particular section. So that number of students will always be a numeric form. So these numeric data can be known as the quantitative data, which represents the quantity of particular data. And as compared to quantitative data, qualitative data is simply used to define the things, or to, for suppose if you are having to compare the items, just like amounts, characteristics, items, times and frequencies. So these kind of data comes under the qualitative data. So for the same purpose, for representation of these kind of data, simply Pareto diagram is used. So data is in this, the data is displayed either horizontally or vertically, and it allows the viewers simply, just I had told that it is allowing the viewers to compare the items. The items can be of different kinds, just like amounts, characteristics, times, features, frequencies. So for displaying these things, simply bar graph is used. The bar are arranged in the order of frequency. So more importantly, the categories which are more important are more emphasized or more focused. By looking at all the bars, it is easy to tell at a glance, or to tell at a summary, just which categories in a set of data can dominate the other. So simply the bar graphs can be either, it can be a single in the form of group, or it can be in the single form, or it can be in the stacked form. The developer of the bar graph is Wilfredo Pareto, and I think his name is, by this name is termed as the Pareto diagram. So he developed the bar graph when he sought to give the economic decision making a more, where he can see that the human faces by plotting the data to the graph papers with the income on one axis and the number of people at the different axis, and the different income levels on the other axis. So the results were striking her mind. So they showed that dramatically the disparity between the rich and the poor in each era over the course of centuries. So by emphasizing on this, or by focusing on this thing, he developed the bar graph. This is the simple pictorial representation of the bar graph. Here we can see that this is the x-axis and this is the y-axis, and as per the requirement, we plot the data over the x-axis and the y-axis, and then we can form the bar graphs as per the data given in our data sets. Now the second one is pie chart or the circle graph. So this is also another way, or another method to represent the data graphically. So it gets its name from the way it looks like, just like a circular pie. We can see in the next slide that how it looks like. So it just looks like a circular pie that has been cut into the several slices. So this kind of graph is helpful when graphing the qualitative data, just like I am saying in the bar graph. So here, where the information describes a trait or attribute and is not numerical. Here I had already told that the quantitative data is the data which is numerical. So here this kind of graph is also helpful for plotting the qualitative data. So here the information describes a trait or the attributes or the features of a data, not the numerical things it represents. So each slices of the pie basically represents the different categories, and each trait corresponds to the different slices of the pie. Some slices usually noticeable larger than the others. By looking at these pie pieces, you can compare how much of data fits into the particular category or into the particular slice, and which data corresponds to another slice of that particular pie chart. Just like we have already seen in whenever we are going to describe, or when we are going to say the the gas composition in the air. So we simply know that this composition can be easily or can be quickly represented by the pie chart showing the compositions of the gases, just like this is the O2 composition, this is the nitrogen, this is the hydrogen. So simply these things can be properly, or these things can be easily represented by the use of the pie chart. Or just like if you are having the population growth of last few years, so for the same cases we can also have a pie chart for representing this kind of data. So this is the pie chart. Suppose this is the composition of O2, this is H2O water, this is nitrogen, this is helium. So the different compositions of the data sets can be easily represented by the using the pie chart. Okay. The next kind of graph is a histogram. The histogram is also a kind of a statistical graphs which uses the bars. When it displays the data, then it uses the bars. So this kind of graph is basically used to represent the quantitative data. The ranges of the values which are known as the classes are listed at the bottom, and the classes with the greater frequencies have the taller bars. Okay. So with these by weaving these bars, we can easily compare, we can easily differentiate the classes, or we can easily differentiate the values, range of values which are here known as classes. So with the use of the histogram, we can also compare, or we can also differentiate the different classes of data, different sets of data. So histogram often just like in the bar graph, we have also a bars by which we can compare the different kinds of data, different sets of data. So similarly, here also a histogram also looks similar to a bar graph, but they are different because of the level of the measurement of the data. The bar graph is basically used for the categorical data, for the quantitative data, for the featureable data, for the frequency of the categorical data, and here the histogram is used for the quantitative data. So this is the basic difference between bar graph and histogram. So bar graphs measure the frequency of categorical data, features of the data. The categorical variable is one that have two or more categories, just like a gender, hair color. And comparatively, histograms, if we say that what is the purpose of using histograms, so comparatively histograms are used for representing those data that involves the ordinary variables, or the things that are not easily quantified, just like feelings or opinions. So the opinions cannot be easily verified, they have the range of value, just like someone is having opinions. Just like for example, if I am talking about the opinion, so just like what we have opinion, we have the range of values, just like 1 to 5, that for a particular problem what is your opinion. So if just like for example, if you are taking a product, suppose for example if you are surveying a product, and I am going to take a survey for different viewers, and I had plotted the 5 range of values, just like 1 to 5, and in these range of values one has to give his opinion. Just like for that particular product, the one is simply saying okay, 2 is good, 3 is very good, and suppose we can also say that 1 is very poor, 2 is poor, 3 is average, 4 is very good, and the 5th is excellent. And we can have different or more than these 5 range of values. So for example, if we are having these kinds of variables or these kinds of things, then for that purpose we are going to use the histograms. This is the pictorial representations of the histogram. Just like this x-axis is showing the travel time in minutes, and this is the proportion of people per 1 minute interval. So here we can see that the histogram is up, and the scale of the histogram is up and down. So as per the data given to the user, he or she had plotted the same things over the histogram, that the travel time in minutes and the proportion of people per 1 minute interval. This is the proportion of people here, and this is the travel time in minutes. Okay. So simply we used to plot the in ordinary variables or the quantitative data over the histogram. And at a summary, we can say that the bar graph is basically used to represent the qualitative data. And if we are focusing on the features of the categorical data or the frequency of the categorical data, then we simply use the bar graphs. stem and leaf plot. Basically, this kind of plot is, I think this is not, most of the people are not familiar with this kind of statistical graph, because bar graph, histograms and pie charts are simple, and most of the persons are familiar with this statistical graph. But stem and leaf plot is a kind of new kind of statistical graph. It breaks the each value of the quantitative. It also used to represent the quantitative data, but what it do, it simply breaks each values of the quantitative data sets into the two pieces. The one is known as stem, which is typically used to represent the highest place value, and the leaf for the other place values. So it basically provides a list of data values in a compact form. For example, if the example is given here, for example, if we are using this graph to review the student test scores of 84, 65 and up to 90. So the stems will be 6, 7, 8, 9 corresponding to the 10 places of the data, and the leaves are the numbers to the right of a solid line, which would be 0, 0, 1 next to the 9, 3, 4, 8, 9 next to the 8, 2, 5, 8 next to the 7 and 2 next to the 6. So this would show you that the 4 students scored in the 90th percentage and the percentile, and the 3 students in the 80th percentile, 2 in the 70th percentile and 1 in the 60th percentile. So you won't be able to see how well students in each percentile performed here, making this a good graph to understand how well students comprehend the material. So you would even be here, what happened here, by using the stem and leaf plot, one can be able to see, just like for the similar example which I had discussed here, using this kind of graph we can easily see how well students in each percentile are performing. Okay, that suppose for example, if we are using some another kind of graph, then what happens is the roll numbers of the students are plotted over the x-axis and the percentage of the students are plotted over the y-axis, and simply what we are doing, we are plotting the percentage as per student. But what this stem and leaf plot do, it basically distributes the scores of the students into the leaf and stem plot, differentiate between these two, and after that, with this stem and leaf plot, we can easily view that how much students are scoring in the 90th percentile, how many students are scoring in the 80th percentile, how many students are comes under the 70th percentile, and how many students comes under the 60th percentile. So basically, this graph is a good graph in understanding that how well the for the given example, that how well the students are performing over the different categories. Okay. The next one is dot plot. Basically, the dot plot is a hybrid graph, or it is a hybrid model, we can say, between the histogram and a stem and a leaf plot. Means it is a combination of these two graphs, the histogram and a stem and a leaf plot. So each quantitative data which is which becomes a dot or a point that is placed above the appropriate class values. So basically what happens, the dot plot just as I had told that it is a hybrid between a histogram and this stem and a leaf plot. So each and every quantitative data values, it becomes a dot value. Each quantitative data values become a dot or a point value, which is placed above the appropriate class values. If you are having a class values, then that particular quantitative data values will be placed above the appropriate class values. Whereas the histograms uses the rectangles or the bars. So these graphs uses the dots here, which dots are joined together with a simple line, and then that dot provides the good way to compare how long it takes a group of 6 or 7 individuals to make the breakfast. For example, to show the percentage of people in various countries who have access to electricity. So these two are the different examples which uses the dot plot for representing the different kinds of data. So just like for the first example, if you are going to compare that how long it takes a group of 6 or 7 individuals to make a breakfast. So for this problem we can use the dot plot. The second example is that if you are going to show the percentage of people in various countries, those who have access to electricity. So for that comparison we can also use the dot plot. This is the pictorial representation. So here we have some symbolic representations just like squares, plus and asterisks. So the simple squares are known as the proxies. The squares which are filled with the blue colors are known as self. The plus symbol is known as self norm and the asterisk symbol is known as the proxy norm. So each kid has the first measure self and the proxy measures. These are the norms. These are the norms which have the index, school, friends, family, motions, body, and these are the some things which we can see in each and every plot or each and every classes. These are the classes 1, 2, 3, 4, 5, 6, 7, 4, 5, 6 and 1, 2, 3, 4, 5, 6, and this had the different classes 8, then 87, then the 97. Okay, because this 87 and 97 is the combination of some classes which have the both, which is consisting the both features of both the classes. So simply this is the, on the x-axis we have plotted the scores, and here we have different dimensions. The dimensions are the index, school, friends, family, motions or body. So for each kid we are first measuring the self and the proxies, and after that the proxy norms and the self norms. The next one is scatter plot. Basically this statistical graph displays the data which is paired by the horizontal axis and the vertical axis. The statistical tools of the correlation and the regressions are then used to show the trends on this kind of statistical graph. So basically it looks like a simple line or the curve which is moving up or down from the left to right along with the graphs with the points scattered along the line. So this scatter plot helps you to uncover the more information about the any data sets, which includes the overall trend among the variables. If we are having any outlier values from the overall trend, then scatter plot can be able to identify that outliers, the shape of the any trend and the strength of the any trend. The simple trend is simply the up and downs, just like up and downs. Suppose this curve is known as a trend. This is the scatter plot which are scattered over there, and we are going to plot a straight line, a single line over these plots. So basically these scatter plots are used to find the relationship or correlationship and the regression analysis problems. And the next one is time series graphs. Basically time series graphs are used for the time data, just like for if you are having a data of selling of refrigerator during the summer season, or selling of AC machines during the summer seasons. So this, if you are having this kind of data, just like the data which are correspondingly point out to the different points of time. So this kind of graph is basically used for that kind of purpose. This kind of graph measures the trends over the time. Time frames can be minutes, seconds or hours, month or years also, decades also, centuries also. So suppose if you are going to use this kind of graph to the population of the US over the course of the centuries, so the y-axis would list the growing population and the x-axis would list the years, just like over which years you are going to calculate. So the years can be plotted over the x-axis and the population over the y-axis, just like in this given diagram. There is the years and this is the total population, which can be millions, or that thing is not displayed here, only the numeric values are displayed here. We can represent over this that the y-axis shows the data in the million form. Okay, so this kind of data can be easily represented by the time series graph. So that's all today. So today I had discussed about the statistical graphs, why we use statistical graphs, and the 7 kinds of statistical graphs which we can use for the different purposes of for representing the different kinds of data, just like qualitative data and quantitative data. Thanks.